Okay, so with this question, the process is a bit longer, okay, than the previous two questions, because if you notice at the end, they actually want you to find the distance that he travels, okay, before coming to rest. Okay, so they're not asking for the time in this case. They're not asking for anything to do with speed in relation to him slowing down. Okay, they want the distance. So we refer to distance as like the displacement, and we're going to use the letter x for that. Okay, but we've got quite a bit of work to do before we get to that stage. So let's sort of model it here in a force diagram. We've got this man, it says, in a go-kart, yeah? Combined mass of 90 kilograms. So we just considered him as one sort of particle, okay? Right, 90 kilograms, traveling along a horizontal surface at 24 meters per second when he sees a red light directly ahead, okay? So he's in a go-kart, and obviously he's obeying the traffic light system, okay? So he immediately disengages the engine, okay, and applies the brakes, okay, which together with other resistances produce a total resisting force of 40 plus 5 newtons. So we've got our resistant force here, opposing motion, and think about it, because he disengages the engine, he's not, what that means is he's not pressing the accelerator anymore, yeah? Okay, so the engine sort of doesn't produce any driving force forward, and he's pressing those brakes, isn't he? So he's got here, we've got here the resistance here, okay, due to that, okay, and the friction, of course, as well. So it talks about other resistances, the friction, the air resistance, okay, and of course those brakes that he's pressing, okay, produces this resistance. But he's still moving forward, isn't he? Okay, so remember now to have our direction of motion, okay, that way. So we have A going that way. Okay, the acceleration point is in the direction of motion. Okay, but of course there's no forward force. We've just got these resistant forces. So as before, okay, and as in all the cases here, because we have motion, okay, we're going to apply Newton's second law. And remember what I like to do here in direction of increasing motion, okay? Right, so that sort of helps me with the understanding then of this formula. So with Newton's second law, it states that resultant force is equal to mass times acceleration. So the resultant force means, well, there's the forward force, which is 0, take away the resistant force, which is all of that there, yeah? And that will equal to my mass, which is 90, times my acceleration, which is A, yeah? Okay, so we are going to then replace A, okay, with what we know A to be, which is dvdt, okay? So I can say, look, since A is equal to dvdt, I've got this then, okay, now I don't need to write 0 anymore, I can just write minus 40 plus 5v equals to 90 dvdt. I'm then going to separate the variables, okay, as before. So separating the variables. Be careful how you do this, okay, and just like in the previous videos, you know, we'd obviously take that dt over to the side, okay, so get the t's on this side, and I'll take that bracket then, because it's involving v, over to the right hand side, but keep the minus there, yeah? Okay, so minus, put it outside the integral, yeah? Because it's a constant, it's minus 1. And that will equal to then, on this side, okay, we'll keep the 90 there, alright? And again, write the 90 outside the integral, because it's a constant. So then in here, because I'm taking that over and dividing, I have 1 over 40 plus 5v dv. Okay, I can then go about integrating this, okay? Now, of course, we've got 1 dt there, yeah? So when I integrate 1 with respect to t, I just get t, don't I? And there's a minus there, so minus t. On this side, you need to appreciate it's linear on the bottom, so we can use ln, okay? It'll be ln when you integrate. But you've got to remember, okay, using the method of integration for ln. When you differentiate the bottom, you need to get the top. Okay. Now, differentiate the bottom, I get 5. I haven't got 5 at the top there. Okay. So what I'm going to do, I'm going to multiply top by 5. Yeah. So now I've got 5 there. In other words, when I differentiate the bottom, I get that on the top. I get 5 on the top because I've multiplied this fraction by 5. In other words, I've made it 5 times bigger, haven't I? And if I make it 5 times bigger, I need to compensate. So what I do then on the outside, I divide by 5. Okay, so I compensated then. So I've made the fraction 5 times bigger, and I integrate it, but I'm compensating then by dividing the result by 5. So I'm paying back, and everything's fine. So then I've got 90 over 5, which is 18, and then I've got ln then of this, okay, 40 plus 5b. Don't forget then to put your constant then of integration in, okay. And then I'm told at the start, yeah, it's travelling along a horizontal surface at 24 meters per second. Okay, that's what it says at the beginning, isn't it? So you can say, look, when t is 0, v is 24. So I can put that in. 0 equals to 18 ln 40 plus 5 times 24 plus c. Okay, and if I work that out, I get c then to be minus 18 ln 160. Okay, because that's 160 in there. Take it over and I get my value for c. So plug it in, so I get minus t equals to 18 ln 40 plus 5v minus 18 ln 160. Okay, change the signs there, so make that positive t. So then I make that negative and I make that positive, so I can write it the other way around. ln 160, take away 18 ln 40 plus 5v. Okay, I can then factorize out 18 here. So 18 ln 160, take away ln 40 plus 5v. And we'll continue this then in part 2 of the video.